Hello. In this video, we're going to learn how to plot and make graphs in Python using the matplotlib module. The data that we're going to be using is the shapes of grapevine leaves. These are XY coordinates from 15 different Vitis and Ampelopsis species. Ampelopsis is a very closely related genus to Vitis. These are points that define the outline of the shape. And as you can see in this cell, and this data is in your notebook too, this is a series of lists where the lists are the X and the Y values for these different species. And the species names are indicated by a capital letter for the genus and the first three letters of the species epithet. So we execute this cell so that we have all the data of the shapes of leaves. And to make our graphs in Python, we use a module called matplotlib. Modules in Python are sets of functions and statements, and they are usually used for very specialized functions. In this case, matplotlib is very generalist because it's used just for graphing overall. To use a module, we first have to import it. So we type import, and we type the module that we would like. In this case, we don't want to load in the entire module of matplotlib, but just a submodule, and this submodule is called pyplot. When we use functions from a module, we have to refer back to the module by name. It would be a lot to keep on typing matplotlib every single time, so we can import matplotlib as plt, so that we only have to type plt every time that we want to use it. There's just one more bit of code that we use for matplotlib when we use a Jupyter Notebook, and it's matplotlib inline. And this allows us to better visualize the graphs within the Jupyter Notebook as we write our code. So to import matplotlib, all we do is we press Shift-Enter. Making a plot using matplotlib is extremely easy. So we have to refer back to the module, which we can refer to now just as plt, and we use the function plot. Within the parentheses, we have to put a list of numbers. And let's use the data from Ampelopsis acutifolia, but just the X values. So this is a list of the X values of the coordinates of the leaf for this species. We press Shift-Enter, and we get a graph. What we have is we have a list of X values, and so matplotlib has took upon itself to interpret these as Y values. And we didn't supply any X values, and there's 12 of these values. So it just goes, 13 of these values, so it just goes through the list and assigns each of these values a sequential number. And that's how it makes this very line graph looking plot. Of course, we could do the exact same thing, but with the Y values. And now matplotlib is interpreting the list of Y values as sequential numbers, again, making this line graph type thing. But we are dealing with a shape, and we have data that is X and Y coordinates. So into the plot function, you can also put two lists. So we will put the first list, and matplotlib is expecting X values, and then we will put the second list of values, and matplotlib is expecting Y values. And now we get something that looks like a leaf. So you know what you're looking at. These are very beautiful leaves. They're highly dissected, which means they have this very severe lobing. What you're looking at is the middle of the leaf here, and then two lobes on each side. So this is a highly lobed, beautiful leaf, and with X and Y values, we get the shape that we were looking for. plt.plot will usually create these line graphs, but there's several other types of graphs that we could make. What if we don't want a line graph, but rather we want points, like in a scatter plot? So then we use the function plt.scatter. And instead of getting a line, now we get scattered plots. Another function is called fill. And this is very useful for the data that we're looking at because it'll treat the data as if it's a filled polygon. So if we use the fill function, then we actually get a closed contour. We actually get a shape. One of the nicest things about matplotlib is that you can keep on adding elements to a figure. So we're going to call up a figure with plt.plot, the line graph, but we could add more data to this. So we could make another plot and call up the scatter function. And now we get the points on our graph as well. And we can even add the fill function as well. So for all intents and purposes, we have just added 3 different data types, sets of data. Even though they're the same data, these are, you could have put different data in here. And we've called 3 different functions. And just by calling up the plot function and others after it within a cell, what happens is that we keep on plotting over and over the same data. And this can give you a lot of power and versatility in the types of graphs that you can make. Let's start looking at some other ways to modify our graphs. What if we want to zoom in or create X limits or Y limits for our axis? Let's say we only wanted the x-axis to go from -100 to +100, and that we also want the y-axis only to go from -100 to 100 as well. We can just, again, add on more functions, xlim and ylim, and there you can see now that our x and y axis has been modified. Maybe we really don't care for all these default colors that are here, or the sizes and proportions of things. Let's start modifying this. So the base colors are indicated by single letters. And there is a link that is provided in your notebook that you can look up what all of these are. So K actually stands for black, the K at the end of black. And we can see that our line is now black. We can also use line style, and there's a link of the different line styles that you can use in Python. These are indicated by colons and dashes and periods. And if you use a colon, now you can see that we have a dotted line. And you can also change the line width. So let's say that we want to make this bigger, and we can change that as well. You don't have to refer to these single letter colors. There's also a rich color scheme that you can refer to all the colors by their names, like dark orange. And so now you can see that our points in our scatter plot are dark orange. Maybe we want them bigger, so we type S for size. And let's make them really big. So there we have our points. And for the fill, another way that you can specify color even more powerfully is through something called a hex code. And hex codes are a very short code of only 6 digits, and they always begin with a hashtag. So we put our hex code, and there's a website, again, in your notebook that will allow you to create your own hex codes. I picked green because we're dealing with a leaf. So there's multiple ways that you can determine colors, and so you have a lot of choices there. And then there's another variable which is called alpha. And alpha is transparency. So an alpha of 1 is completely opaque, but an alpha of 0 is completely transparent. And so we can lighten up our fill, and now we can see more some of the points behind our fill. So those are just some of the ways that you can modify the colors, the line styles, the line widths. There's multiple ways to modify color, sizes, transparency through the alpha. So you have lots of choices at your disposal. Let's try to modify the actual dimensions and the graph itself. Let's get the aspect ratio equal. Maybe you didn't notice it, but this leaf is a little stretched in its width. Let's make the axes equal. So you can specify specifically the axes, and then there's another function, set aspect. And you can say equal, so that we have an equal aspect ratio. But there's a couple ways to do it. You can say box, which will literally create the same size of each axis, or you can keep the aspect ratio of the whole graph, but keep the equal axis ticks on each side. But let's go back to box to create a perfect box graph. We can add a title if we want, and that's just plt.title. You give it a string. This species is Ampelopsis acutifolia. You can say what sort of font size you want for your title. Let's make it pretty big. You can create a style. Let's call it, let's make it italic, like a species name should be. And then you can even make it bold through something called font weight. And we set that equal to bold. So that gives us a title, and we can control whether it's italic and whether it is bold. And we can also create X and Y labels for our axes, and we just do that through plt.x label. We'll just call these X values for the x-axis, and we can create a Y label, and we will call these Y values. And there you go. We have axis labels as well. We can even go one step further. What if we just want the pretty picture of our shape and we don't want any of these axes? There's just something called axes, and you can turn it on or you can turn it off. So that's how you get just a beautiful shape without all that extra information of the axes. So that gives you a lot of choices and control of how your graph is going to look. It's already implied that you can put different data types onto the same graph, but we've been using the same data. So let's really quickly look at what happens when we try to change things up with very different types of data. So let's create again a plot of this Ampelopsis acutifolia. We'll change the colors and the line styles a bit. And we're going to put a new variable in here, and it is called label for this particular plot. And we are calling this particular plot and this particular set of data Ampelopsis acutifolia. But now let's copy and paste this, and let's put in a very different type of data. We'll put in another species. Let's make this species a Vitis species, Vitis riparia. This is a very common species. It's found all throughout the northeastern United States, going into Canada. If you go on the Grand and the Red Cedar rivers, the wild grapes that you see, these are mostly Vitis riparia. So this is an extremely common wild grapevine species. Let's give it a different color, cornflower blue, and we are going to give it a name as well. This one is Vitis riparia. And then we're going to do one more data, and this one is going to be Vitis rupestris. This is a species that goes down into Texas in the southern part of the United States up to Missouri. It hybridizes, that is, it mates and creates progeny with the Vitis riparia. And both Vitis riparia and rupestris are used as rootstock species throughout the world. So there we have our three different data types. And let's just quickly see what we have. You can see we have these three different data types. we probably want to create an aspect ratio that is more pleasing. So let's use our equal box. And we need a title. So let's say comparing the leaf shapes of 3 grapevine species. We have all our other things, our X labels, our Y labels, and our on. But notice because we have different data sets, and we also use these labels for each of the plots, we can now add something else, plt legend. And we want the location of this to be in the upper right, let's say. So let's see what that looks like. So here we go. We have our 3 different data sets in different colors. Because we put labels on each of the plots, we can use plt legend. You can say where you want the legend. Let's say we want it in the lower left. Instead, you can do something like that. Or you can also even just say best, and Python will try to figure out the best place for your legend. So again, you can add very different data sets and keep on plotting on top of plots. And this gives you a lot of choices and a lot of versatility and power in the graphs that you can create with matplotlib. So let's say now that you actually didn't want to have all your data on top of each other. Probably you usually don't want this to be the case. It'll probably only work out sometimes. Let's say you want separate multiple graphs, that you want subplots. So there's a function called subplot. We need to import another module, and it is called numpy. Like matplotlib, this is an extremely important module in Python. This module allows you to work with something called arrays. We haven't got to arrays yet, and we eventually will. Arrays are very powerful ways to do data analysis. But for now, we need numpy because we need this special data type of array. If we want to create subplots, what we do is we call the subplots function, and we specify how many rows and how many columns we want. And we can even put the figure size that we would like with the length and the width. So we call the subplots function. We say how many rows. The rows are always first. How many rows do we want? How many columns do we want? We're going to create 4 subplots in this example. And we'll get to this later, but we're actually creating 2 things at once. And so we call this catching the output. And so we're creating a figure, but we're also creating these axes. The axes are the rows and the columns. They're the independent and individual graphs that we're going to make. And you'll see how that works in just a second. We have to put one more little snippet of code when we make these subplots, and this is called the ravel function. And this has to do with the arrays, and don't worry about it for now, but it's a necessary item when we make subplots. So this is how you set up a subplot. You have to import numpy, and you have to call subplots, and you create a figure, and you create axes, just like this. And you call this ravel function as well. When you want to make the different graphs, now all you do is you refer to them as if they were indexing just like a list, just like we just learned about. Just like you index elements of strings and lists, you can index the 4 different graphs that we're doing in this example. And you just call them up one by one. So let's look at our Ampelopsis acutifolia again. That will be one of the graphs. We can also look at the other Ampelopsis species. One of them has a really funny name. This is Ampelopsis brevipedunculata. Sorry, I probably messed that up. We have Ampelopsis cordata. And let's look at one of the Vitis species as well. Let's look at Vitis acerifolia. So there we go. We've set up our subplots, but we have to refer to each of these by index one after the other. So as you can see, we've set up a single figure with multiple axes, and we index the axes starting with 0 and going forward. And we've specified how many rows and columns of graphs that we want. So this is the output. We have, let's make this a little smaller, maybe 7 by 7, so we can see it. We have created our first subplots, 2 rows, 2 columns, and we go 0, 1, 2, 3. Looking at each plot. You can elaborate all the different details for each of these different graphs, again, by referring to the index of the axes. So let's take this a little further. For the whole graph, you can make a title if you want. This function is called fig.subtitle. We're modifying the whole figure. That's why we do fig.subtitle instead of the axes. So let's call this the shapes of grapevine leaves. And let's make it a little bigger. So it's the title of the whole thing. And then let's modify some of these a bit. Let's do a fill plot instead. Let's give us some space here. Let's make the color of the fill a green of some sort. Let's use a medium sea green. Again, all these colors are in the link that is provided. Let's give them individual titles for each of these so we know which species that we're looking at. So we set the title just for this axis. We call it Ampelopsis cutifolia. The font size equals a little smaller than the overall graph. And let's make this italic, as it should be properly for any species. We definitely want to specify the aspect ratio. You can set that as equal, and data lim. And let's turn these axes off. So we refer to that, then we do axes, and we set this as off. So we can now do this for each and every one just through copy and paste. This can be a little tedious sometimes, but it's how you get control of each and every plot. So this is Brevipedunculata. Let me copy and paste this very hard name. Oh, there we go. So yes, that's Brevipedunculata. And now let's do Ampelopsis cordata. And we change that, and this is now axis 2. And just one more, we're going to do a Serifolia. So this is now Vitis acerifolia. And hopefully that is everything. So let's see what we got. Oh, something is off here. Oh, we didn't set a third graph. There we go. And maybe we need our font sizes just a little smaller. So let's call this 25, and maybe let's make these 16 or something like that. And hopefully everything fits as it should. There you go. So this is a subplot. As you saw, this took an incredible amount of time, but it allows us to set the details for each of these graphs independently. We call the subplots rows, columns. We have the overall figure and the axes. The axes, through indexing, refer to each of these graphs, which gives us the power and control to make each of the graphs whatever we wanted to. If we wanted, we could have made each of these graphs different colors, different sizes, all sorts of different things that would allow us to create any graph that we wanted to. So in this video, we learned about matplotlib, how to create plots, scatter plots, how to create filled polygons, how to manipulate shape, size, text, font size, and then we learned how to plot data on top of each other and how to use a legend. And then finally, we learned how to create subplots. So that's all for this video. Thanks for listening.